In this video, we're going to talk about the second derivative test, which is an alternative of first derivative test. But second derivative test, it fails in some cases. For example, if I want to do the second derivative test to check the local maximum, local minimum, then we have to start always the same way by doing g prime of x. So we derive the first time. Then g prime of x equals to 0 to get the stationary values. Now, instead of doing table of variations, here how we use the second derivative test. So we have to derive one more time to get g double prime of x. Now, this test fails if you derive and then you get the g double prime of x equals to 0. So if you solve a function, let's say it is, if you have g of x equals 3x plus 5, then you do g prime of x equals to 3, then you need to derive one more time and you get g double prime of x equals to 0. Then you cannot use the second derivative test. In this case, we say it fails. Okay, now, so doing these steps, getting g double prime of x, we have to do the following. Once you get g double prime of x and you get stationary values, let's say x1, x2, maybe you have more, x3, x4, maybe you have only one value, it depends. You're gonna take the x1, replace it in g double prime, and you take x2, replace it in g double prime. In case you replace the x value in g double prime and you get an answer that is negative, so if the number you get is negative, in this case we say we have a local maximum. If you replace the value of x, which is stationary value, in g double prime and you get an answer that is positive, we say we have a local minimum. As simple as this. Now, let's see the example we did in the previous video using the first derivative test. We had one local maximum, one local minimum. So let's check if we can get them using the second derivative test. So the first step, we have to do g prime, which is 12x squared plus 6x minus 6. Second step, we need to do g prime of x equals to 0 and get the stationary values. And we got 1 over 2 and x equals negative 1. Now, I don't do a table of variation. Instead, we do the derivative one more time and we get 24x plus 6. So I derive g prime one more time. Now, we replace the first value of x. These are the stationary values. So we replace, instead of x, half. So we get 24 multiplied by half plus 6, which is 12 plus 6, and the answer is positive. Once it's positive, directly I can conclude that it is a local minimum. Now we replace negative 1, 24 multiplied by negative 1 plus 6, and we're gonna get minus 24 plus 6, which is negative 18. It's negative, so I conclude we have a local maximum. If you want to find the full point, then you replace the x half in g of x, the x equals negative 1 in g of x. Now, in case, as a note, I will make a video about this later on. If you replace an x value in g double prime and you get it to be 0, in this case we call this point an inflection point. We'll talk about this later.